Was talking about. And the reason why we actually got here is that at Dockler we basically had a relatively big code base that we needed to make work in JavaScript, and we did a lot of automation of that stuff. But we came out with pretty big binaries and many bugs and stuff like that, and we wanted to somehow find a way to solve all these things. Didn't really know where to start. Of course, being in the web, we heard of React, and we looked at that a lot because it promises to solve all of your problems. Turns out it gets you really far, but then again, it's all marketing is the other half of of its brand, I would have to say. And the other thing is that if you look at because React only gives you part of things, like it tells you how you can construct the view part, the visual part of your application, but it doesn't on its own tell you how to hold your data. There's other libraries for that, and if you go down that path, at some point you completely land in functional land, and you can throw away all the code that you had before, and that for us was not an option. We needed actually something that would integrate into an OOP landscape. So kind of, go ahead without sacrificing everything at the altar of the almighty functional gods. And so we used many functional aspects like unidirectional data flow, composition, all that kind of stuff, but tried to make it object-oriented still and easy to understand somehow. And I called this thing Coconut because I actually didn't want to write it because I hate frameworks. I think they are silly because at some point you always hit a wall and then you just die instantly. And I think it's kind of the quest for a holy grail, and I like to compare it to the Knights of the Holy Grail from Monty Python and their horses. So yeah, turns out that the framework was actually turned out a lot better than I expected. So otherwise I wouldn't be presenting this. And so it's quite roughly divided into 3 parts that you might want to know about. One is the data layer that allows you to create observable models. We will go in depth to what that means. Then there's a UI layer which does half of what React does. It composites views into one another and kind of figures out when they need to update and all this kind of stuff. And then it can push out to 2 different renderers. One of them is just based on a very small standalone JavaScript library that we found that was, did not have all the complicated stuff in React that we're not going to use. And the other one is actually you can render out through React, and but for now it only works with React Native. So that's something that Kevin actually wanted to create native applications with Coconut. And so, the interesting part about it is that it's all, except from parts that are in the renderer, it's all written in Haxe. It's all statically typed and safe, and you get all kinds of stuff, but we'll see that in detail. So that was just for some introduction. And so I guess the most core aspect of what happens. Let's just do this in a standalone thing. The most important aspect. Sorry.
Maybe you should switch the theme to the right one, so it's more visible.
Okay. Yeah. Sure. Theme. This one or this one?
Yes.
Okay. Great. Let's close this sidebar. And let's get rid of all this other stuff. Whoop. So we can just talk about the thing that that's kind of interesting. And where was that? Yeah. Okay. So yeah. Wow. That's great. So we have this very at the very core of all this stuff is this data structure, which is called an observable, which exists in the wonderful Think State library. Okay, I broke completion once more, as always. No, that's for me. It's normal, and I don't. I think I'm definitely part of the problem. So yeah, there are observables and there are states, and these are okay. A state is a container for just one value that may change over time. So let's create a state. Let's make a state of, I don't know. Let's give it some name. New state John, maybe. Okay, let's call it first name. And the last name might be Doe or something. Okay, and so then you have these states, and you can first name set something something, for example. So you change the value, and it only can go to the type. So in this case, it will tell you string. So it's just a container for a value of one type. And if you call observe on that thing, then it becomes an observable, which is basically the same thing, just wrapped under an abstract that makes it read-only. So nobody else can do that. And this is a way that you can expose data for other people to subscribe on. And the interesting thing is because it lives in just one first class value, is that you can make kind of like combinations on it. So you can say, let's observe the first state and let's combine this with the last name. And so then now we need a function that can actually combine these two states. So first and last, and it might return first, last, or I don't know. Maybe let's go the formal way. And so this is the last name, right? And yeah, the full name, exactly. And so once you have an observable, you can decide to bind it somewhere to some callback to get out the value, and you can let's just trace it in this case. I think I can open this right here, and so we see. This is not very interesting, but okay. So we see it's a Dojan somehow comes out of it. So now what we, for the sake of simplicity, okay, let's make a varq and timer is a new hex timer. So let's see how this thing behaves over time. That's what actually makes it interesting. Timer run, and what this thing is gonna do is so this is going to be an array of functions that we want to distribute over time. And let's run a function every, I don't know, 100 milliseconds, for example. So let's switch over whatever is at the beginning of the queue. And if we get nothing, then we're basically done here, I guess. And otherwise, we will just call the function. So this is just so that I don't have to actually have a UI that makes input. I'm just going to distribute some stuff over time. So what am I going to do? So for example, in the first step, I'm going to change. I'm going to set the last name to, I don't know, Cousteau, or whatever the guy was written like. And then the first and the second, I'm going to make the first name be Jacques. First name is Jacques. And then maybe in the next function, I'm actually going to go back to first name is John. but at the same time, I'm going to also say that the last name should be first name and last name is Do. And then let's see just what that does. Too many arguments, that's helpful. Yeah. Okay, and so now we can load this. And we see that it does first John Doe, then John Cousteau, then Cousteau Jacques, and then John Doe, man. Okay. And so the interesting thing is actually that how observables work internally is that they have an invalidation, which is always synchronous. So as soon as you change something in a dependency graph, the thing gets flagged as dirty, and then by default, like for example in the browser, every frame then at some point it's going to get validated. But it's lazy, like it's sitting there, like just to make that point. Like you shouldn't really be causing side effects in these computations, but let's just say that we will. Recompute, and let's return right here. Oh, well, actually, we should just write compute anyway. And so we see that the computation is actually never executed because nobody wants the value. So this is actually quite cool because you can set up a couple of observables and do complex things. And it's only actually when the state is needed that it is accessed. So let's take this one step further. First and last, and let's here return. So let's make these strings, and then let's return this bit. And these will have to be, whoa, okay, last, first. Okay, so this basically constructs a person which has multiple observable properties. Yeah, let's just leave this here. And so, so what we can do now, just to make it a bit more complicated, we can say var Jacques, French is so complicated sometimes, is a person called Jacques Cousteau, yes. And the other guy, for example, so that's John is still, no. Maybe like so, I have no idea. And John Doe. And then, so these guys are going to be a team, but of course every team totally needs a leader. So we're going to say, this is a new state, and in the beginning Jacques will take the lead. And so now this is kind of a not very handy way to access all that state, but so there's this little helper that exists where you can just say, okay, I wanna create an observable from stuff that I know will be changing over time, but I don't really want to be bothering doing all this functional stuff with combining things through other functions and all that. So I can create a kind of like a auto observable, and no, well, I'm not actually going to. So yeah, the full name will be an auto observable, and what it's going to be is it's going to look at whoever the leader is, and this guy will be having a first name, and we can just grab the value out of the state directly, and combine that with, I don't know, yeah, this time it's the other way around. Why not? Combine this like so. What am I doing wrong? Okay, it's just VS Code doing interesting things. So basically, I have to make a function that evaluates to something, and it does that while getting data that itself was observable. And if I bind this thing right now, so I can, for example, say Jacques first name should be, I don't know, Paul. Who's Jacques? What did I call this guy? First name? Ah, yeah, set Paul. And then I can, for example, say leader set, well, actually, I can say John will be Paul. And then I can say the leader will become John in this case. And when I now, for example, set John's name, first name to, I don't know, Brad. Then this might actually compile, yeah, okay. And so, okay, I'm doing something terribly wrong right here. First name, yeah, okay, last name. And so the thing is, it doesn't, one does not really, I can't really show that so easily. Or can I? So, but basically, like, it works really well with all these nested things. So there's stuff, and it changes somewhere in between in the graph, and it bubbles through. And if we had a few more examples, I mean, one could write a bit more code to show that the part of the dependency graph that you're not actually accessing because it's somewhere else never gets evaluated. I mean, you could, okay, let's make this is Jacques in charge true. And then you could say var leader is, for example, is Jacques in charge, observe, and then let's map that, or let's use another auto observable to really reach maximum confusion. So, and we're going to return if Jacques is in charge, then we're going to, in fact, return Jacques, and otherwise we're going to return John. What? Semicolon? No? Yes? We'll see. Has no field set. Who has no field set? Ah, yeah. Okay. So, what did I say? Yeah. Okay. So, is Jacques in charge? It becomes false, you know, in this case. And we should basically get the same output. Yeah. Okay. And so we actually have all of this different data that flows in, and it's only the relevant parts that get executed. So that becomes really relatively cool. And the way that this would compose up to a UI framework is that if you, let's do it this way, var HTML is actually, again, let's just do it this way. Or HTML full name, just to give you the very rough idea. So then you could just say things like, okay, let's put this in a header tag, and let's just say, for example, leader dot the current value, and let's use the first name is in charge now. Okay. And so you have this HTML that just changes over time when it's relevant, and it all just comes from pure computation. You first take the data that you have at the root of all your troubles, and you compose that into the shape that you would expect in the view, and then the view itself is also just a function that can render things. And then comes kind of the interesting problem. Okay, so now I have a bit of HTML that changes over time. How can I actually display this without throwing everything away? And at that point, you're going to use virtual DOM libraries that then just diff this. And that's basically how you do that. And then you spend 6 months optimizing that and trying to contain the changes so that they don't re-render everything. Okay, so that's just like the very basics of how this works. Sorry?
That's the basics, okay.
Sorry?
If I may, why are we doing all this?
Why?
Yeah, so what's the point?
So the point is, like I could write down 100 of these variables and tell you that whenever one of them changes, you have to somehow imperatively update the UI, and you will, if you solve it for 100, then I add one, and you will suffer horribly, basically, because you don't necessarily know where the changes come from, when they come. Like even somebody can set a field somewhere and forget to dispatch an event or all this kind of stuff. And so what we're trying to do instead is have data that is always that can change, and then we can compute new values from that. And if they interest us, we can get them, because the way it works, for example, in event-based systems. So you have, for example, some class that knows if the user is logged in or not, and when the user is logged in, it dispatches a signal, and maybe somebody listens, or maybe they register too late. If they register too late, then it's kind of their problem, but maybe they found out that, okay, the user actually logged in. So now I'm going to use this information to update the UI somewhere, and like the whole flow can become amazingly complex, and at some point you have just totally weird bugs that come out of this. And if instead you say just, okay, this is the value, and this is what you compute next out of it, and this is what you compute next out of it, and then you just say, okay, now that I've declared this, can somebody please propagate the changes for me for free? Then you wind up with something roughly like this.
So we're building some chain, and if something in the chain changes,
it updates, exactly. And so I will, yeah?
But it's not free, as you say. There is some impact on the performance when you use observables and
So yes, there might be. It depends on how you structure your code and your use case. It's just I don't want to chime in with all the other people who say it will solve all of your problems. It will solve many of your problems, and you will of course discover new fun things to think about.
can you show the generated code quickly, just to get a rough idea of what it looks like?
This is all without macros.
Yes, but I mean the JavaScript code.
Ah,
Just so we get a rough idea of how much this becomes.
Even auto is not a macro.
no,
How does it?
it's magic. So yeah, so this is basically what we've written. This is what abstracts do to your code, but I mean, it's nothing really bad. It generates normal code basically, because there's nothing. I mean, there's a funky thing going on in Auto, but other than that, but yeah.
Is this similar to RX, I think, directives?
So yeah, for does anybody here know RX, JS, or all of that kind of stuff? Yeah, okay. So there is actually, like, if you're interested, there's this, what is it? There's been a pretty nice intro written by this, what's this? Yeah, exactly. By this guy. He's now completely in functional land. And so this is just the very simple, like, Twitter UI of stuff, and when you click away, then you want the next guy to come, and then you refresh, and all this stuff is actually written down in a reactive way, you could say. So I don't ever say, now that I've now that my AJAX request has completed loading the data from the GitHub API, in this case, I want to be updating that DOM. No, I just say, okay, this is where the data comes from, and please, and when some of those buttons are clicked, then some status set, but all of that stuff just trickles through into the UI at some point. And so this is, so he wrote this nice introduction, which, you know, I mean, so there's a lot of stuff to read, and it's on streams, and it's based on our XJS, which is based, I think, on some stuff that Microsoft first did in C# or something like that. And the idea is vaguely the same, except that thinkable observables are generally lazy, like completely, and they're just not. If you don't subscribe, they don't compute or they don't run away or anything. And also, you can query the value at any given point in time. It's just that sometimes in between it's not defined because nobody cares, because we haven't just rendered yet or something like that. But at any given point in time you can ask, whereas RxJS observables really just emit events whenever there's something there, and it can stand for mouse events, and mouse events are not actually like a continuous value. It's like not between two mouse events there would be value, but observables in Tink are really just a value that changes over time. Okay, and so if we wanna have a look at how one might, I don't know, anybody want to see how this scales up to do MVC maybe? Because then we look at something that probably everybody knows. No, that's not. List projects to open. No, this is React. To do. Oh, okay. Well then. Okay. Sorry? So, okay, let's see if this still compiles. Actually, because I've been messing with things a bit recently. Yeah, okay. So, let's just fire this up directly. Yeah, this is something I did for fun. Doesn't really matter. So we actually have two to-do lists, and they share the same data of to-dos, but they have like different filters. So we can actually, you know, we can have one that shows us the complete. And so, for example, if we click here, then the thing, you know, goes up. And I never wrote much code to do that. So to look at the code that I did write to do that, to give you an idea. So basically, okay, this is how the whole thing initializes. It's probably not very interesting. And this is where we need to probably zoom in a little. So yeah, I mean, this is from here to here is actually the entire application, basically, like all the things that you see, all the things UI that happen there. So for example, in here we say we look at how many items in this list are currently active. This is like, I think this is lambda count basically and stuff like that. So you can compose in other functions that don't know anything about observability. It's just this magic of observable auto that makes sure that changes propagate through. So this, for example, that's the little thing that you see right here, you know. So it has 2 items left, 1 item left, and it will just every time that something relevant here changes, so to speak, it finds out that bit and it re-renders just that bit. And then there's just this one little other sub-item to do item view. There we can see it a bit more, there it becomes a bit more interesting, I guess. This component has actually one piece of state that's internal. Whenever you update that from anywhere, the thing is scheduled to re-render. So, and how does that work? So basically, when I double click on the description of the event, then isEditing is set to true. Then therefore the thing re-renders and it enters this other branch where we actually get this input text field. And once we blur, then it goes back out of editing. Okay? And so, so that's what this basically does. And once I blur it, it's back. And I mean, like if we, well, and this is, apparently I found a bug. No, hang on. No, okay. Or maybe I did. Okay, as I was saying, I'm just playing with this. Let's just do it with one thing for now. Build. Let's kill that thing. Yeah. So yeah, essentially, as soon as you start editing this fella, all the communication is there. But so basically, the interesting part is that Coconut is actually relatively good at, in this case, keeping the update loop only between the data that belongs to this view and the view that belongs to that actually presents that data. So all the communication, no, that's the other thing. All the communication is actually going on in this case only within this particular thing. And so this is how you define these classes. You just say what goes in. Then you must create a render function where you use something that looks very much as what Philippe showed. The only difference is that for now the markup also has control structures, and we need that because it's not easy to be reentrant. So for now I put them into the language, but eventually we might actually want to get rid of those. So does anybody have a specific question about this example?
What's the state?
Sorry?
What are the observables? Can you show them?
I'm sorry. This is actually backed by an observable. Yeah. So there's in this part there's a lot of code being generated. So when you set that, why did I do this? Oh, okay. This is, I think, completely irrelevant. And so the way that this is backed by data, and that's where most of the observables actually sit, is we have these to-do item views. To-do items. And these all have to implement model, and right now you can't have inheritance on them. I'm not sure I actually want to add that, but for now that's the way it is. And so they all have these specially marked fields, and everything in the data layer must either be observable or constant, which is actually just a special case of being observable. Like observing a constant is really easy. You know, you look at the value once and then you're done. Experiment concluded. And so it actually checks recursively things like, so for example, I could say here that I want a constant and it's just, I don't know, tags. But I would say that this is an array of strings. And then it's actually going to tell me that array is not acceptable because you could actually get that thing and mutate it in place without anybody ever noticing. So what you can use instead is observable array, which is just like an array, but it has all these features. But it's basically guaranteed at the data layer that all the stuff that you define can't be mutated without other people being able to subscribe to it, you know. Or if you want it immutable, you declare it immutable, then it's just fine. So what you can do instead is, I think you can, for example, there's this immutable lists in yet another library. Okay. So then this becomes okay, but then the thing starts to complain. The constructor is auto-generated to consume one object with fields for all the stuff that you want to have in your model. Things that have such a default value do not need to be passed. They will just default to this. Things that are actually explicitly set to something will be initialized internally. And so the way to fix this compiler error would, for example, be that. And when you look at the object from outside, like let's do that. Where are we? We're here. To-dos. So like the to-do list, for example, has just a bunch of items in it, and by default it's null. Like this is an abstract, so it's okay for it to be null. It's just the empty list is actually null instead of something empty. And if we so we see that it becomes an ordinary getter, and it's actually backed by observables underneath. And if you want to ever go back into functional madness, you can just access this observable fields, and it will have for every observable field that you have the underlying observable in a read-only way, and then you can go back to map, flat map, whatsoever, and do your monad ballet and all of that. Okay, and so yeah, so you have this item which has all of the things that you can basically also see on the screen. It has the list. Sorry, to-do list. We just seen that. So this is just a list of items, and it has this computed variable. So that's just a shortcut to say, okay, this is a property that I want to expose to everybody else. And this is also just a lazily updated observable. Like if nobody ever calls that getter, then it doesn't get computed. But if somebody does, and they subscribe to the changes, then they also get called back whenever it, changes. As we can then basically see here. So, for example, yeah, we could, no? Maybe we could. To-do list has nothing. Total, yes. And so now it's this computed variable, but what is this relevant for? Sorry, I don't. So, yeah, if there's any to-dos at all, then we actually have the footer, because by default the application starts without the footer, and only when there are some, then the footer is rendered. Notice again, I did not have to ever append child anything or all this kind of stuff, because otherwise it would, you would have to write a whole lot of event handling code if you were to somehow take the more conventional route. And so basically that would just be the to-do MVC example. Do we want to look at that in detail? Yeah? Or different questions, yeah?
Well, you started with this simple example of this observable, which returns a string that uses this other observable. And now all the HTML is marked with this AXX.
HXX, yes.
So what happened in between?
What happened in between?
Why do you need this?
So what happened in between is, first of all, like in this whole layer, basically, what you have underneath is observables. Like all of the stuff that is editable, for example, is held in a state. And the setter that is generated goes into that state, and the getter retrieves from that state. And the thing that I showed you in autocompletion here, wherever that was, to do observables, that returns also the same state, only as a read-only type. Okay, so you can get at the data any way you want. So that's where the data emanates. It's held by these observables. And the interesting property that they have is that you can combine them, and there's explicit ways to do that, and then there's this weird observable auto dot thing, which actually, while the function gets evaluated, tracks at runtime which observables you enter, and then knows exactly when to invalidate and unsubscribe and all this kind of stuff. So it handles all subscriptions for you, basically. Okay, and always the minimum. And so with that, you can already have arbitrary values derived from observables. And so then the next step is basically just to have another function that basically takes the state that you want to have and puts it through some type of template. And what you have in the end in this example, and if you look like a bit into the implementation, then you're actually going to see that there's a tink state observable of vnode. So this is just a node from a virtual DOM tree. And so I have this, and this basically is just the internal representation of the view. And then I just take care of not querying that thing too often, you know, and all this kind of stuff, and making sure, or making also sure that it doesn't invalidate too often. But it's really what's powering all of that, and the rest of Coconut is largely, it's two things. It's one, this syntactic sugar, so that you can write this kind of stuff. And the other part is the static type checking, that kind of, because the compiler doesn't have notions of immutable or observable, all this kind of, like, you can't really have these kinds of concepts encoded in the type system, unfortunately. And so you have to do that by hand. So that's the two things it does. You could, for example, render Coconut views into Coconut views from pure observables. Okay? So maybe we want to just try that. Class name view. Well, that's lame. Okay, but extends. Do I have Coconut? Yeah, maybe Coconut UI view. And so we have this first name. That's a string, and we have the last name. That's a string, and I don't know, maybe an on-click. That's a void, just to be able to have some data flow. And so we are going to render this thing, because I'm an extremely lazy person. You can also write this without all the bells and whistles. Totally useful. And so this thing could, for example, have the first name and the last name. And you can say something like onClick equals. So here we're actually going to invoke the onClick function that we've been given from the outside, just if the button itself gets clicked. And let's get Jacques and John back, or at least one of them. So we have this person right here, and so then we're going to say, okay, Jacques, come here. And okay, and then we need, of course, to import more stuff. Importing state stuff. And so instead of rendering this fella, we're just going to render a full name view. And so we're going to say the first name is going to be Jacques first name, and the last name is going to be his last name. Last name, first name. And so we can try to compile this. What does it say? Okay, so I miss the onClick. That's really nice. And so on click, I'm just going to say Jacques. First name. Here it works. Why does it work here? Man, okay. This is so random. It's just going to be Jacques' first name plus, I don't know, XXL. Or something. Jacques.
Java reporting.
Sorry?
Good error reporting.
Yeah, it's pretty, and you get nice autocompletion. 60% of the time it works all the time. So let's see. So we have Jacques Cousteau, and we click, and and we didn't have to go through the data layer if you don't want to. And the interesting thing is that the HXX does is actually figure out how to bind this to this stuff in here. That's kind of like a neat thing. Oh, and the other thing that's also kind of interesting is if we have an event here, like if you don't make this a function, whatever the expression here is, then at least in theory, you also know what kind of event that is. So in this case, we know it's a click event, so we have this client X and all this kind of stuff. So you don't have to, the way it is currently, for example, if you're just using the raw data API, the raw DOM APIs, and you get an event, then you always have to cast the target to something, or I mean, in this case, for example, we know that the target is actually an input element because that's what buttons are and all this kind of stuff. So you can do, pretty cool things. And what's also interesting to know is that this button thing, I think that will not, no, I'm probably messing up some positions, but this is really just a function from this guy that is imported into scope. And that's it. And like if you want to have your own tags, you just define a function somewhere in scope, and you can do that. Like I could for example say, so now let's get a bit more explicit. I could say function button attributes and children, which are probably going to be something. And then in here I can return instead a link with an, totally useless, but let's do it anyway. So where was I? Yeah, so I wanted to make this a link for no good reason. And so what does this thing use? Links have their own kind of weird, yes. Their own kind of weird attributes. So, I mean, this is not necessarily the best way to do that. Where does this guy come from? Anchor attribute. Okay. So I also have to anchor attribute. Sorry. Field render. Sorry? Ah, yes. Thank you. Okay. And so in here we have this thing that also exists in React that kind of just says you wanna be applying all of these attributes here, which in theory should work. Yeah. Okay. So this basically takes the object and it unpacks it into what's calling it, and you can do that with multiple objects, and it's based on the type of the object. It's going to take the properties from the objects that actually have them, and if there's one missing, you're going to get an error message and all this kind of stuff. So like if you have data from multiple objects and you want to somehow chuck it into the same view, it's not a problem. And so magically this seems to compile. Let's see if it does anything. Okay, so now this is a link, and it still kind of works.
By the way, it's actually a little bit confusing at the moment because you have first name and last name in the second call, and you don't need it there because you call the function which already.
I'm sorry, this is silly. So I'm just going to use the children. And I think in that case the compiler will want me to do be explicit about the type here. And where does that live? vdom dot children? No. Children comes from From vnode. Yeah, okay, vnode. Yeah, I'm killing the compiler mode, but it's what I do for a living. Which dot is that?
Yeah, vdone vnode. I think you mean just vnode.
Oh, yeah. So yeah. So now it's actually the, let's test if Jacques is still okay. No, if he's still XXL. Yes, okay, cool.
Quite awkward question. If you wanted the people, the person, to have a looping video, like an image of the looping in the div,
Yeah.
would that be when you click on it to change his name or change somebody else's name in the whole screen?
Yeah.
Would the video just stop, restart?
It shouldn't, but it depends. I mean, there's this whole thing, like if you know React a little bit, you can assist the framework in understanding between renders what is actually meant to be the same by using a key for something. So in this case, let's show it in the to-do list. To-do list view. So here when we're instantiating the to-do items, for example, we also use the item itself as a key because this view really just gets two different values and doesn't really know which value it should create the view for. Like there's no clear notion of identity. Like what am I actually rendering? For example, this function is just a closure that gets created every time the main loop has to run. But yeah, like with usage of keys, you can usually avoid re-rendering of stuff that should not re-render.
So you have something in the framework that says, like, leave this video alone and it can rebuild the stuff around?
I have stuff in the framework that helps it assist, but as always, there's some things that don't work. I mean, it depends on the VDOM that you're using underneath. Like there's different renderers and all this kind of stuff and how it handles that. Like the one that we use for HTML is actually not quite as good as React with keeping selection. Like if you select like a huge chunk of DOM and then you start mutating stuff that's in between, then it's not trivial to keep the selection, but somehow in React they had the manpower to do that properly.
So like, for instance, if you wanted a video to be, like when you click on a button, some of the videos to animate around the screen,
Yeah.
CSS, you'd be able to maintain that without the videos stopping.
I think so, yes. But not necessarily for free, you know. I mean, it depends on the thing, but yeah. I built an application, like a prototype of what we're developing in-house, and there was exactly this problem with stuff restarting and stuff like that. And after some doing, I was able to, you know, just put enough keys in there to make sure that the thing would not re-render. I mean, it was 2 or something, but you know, just understanding the problem was quite interesting in the beginning. There's also plans, because we have actual control structures, we know that we're in a loop, and it's reasonable to assume that the loop variable is actually what you can use as a key, so that will become the default, so that by default it does something meaningful rather than potentially throwing everything away when you re-render a container of stuff. But yeah, it's an ongoing thing, definitely. Okay, any more questions on this? Maybe? No?
Yeah, the same question I asked Philippe. Can this template of HTML be loaded?
At runtime?
Be in an external file and combined compile time?
Yeah, I mean, there's this thing, so for example, in here we could, I mean, it's kind of I don't remember anymore. It's good to write a documentation sometimes, because import. Okay, so here we go. So you can just have an import statement, and then we could just say le button dot HTML or something, and then you can just dump the markup in there and it's going to get loaded. And there's this thing that by default it resolves relative to your file location, which I kind of prefer because I like to keep code together. But if you want to do it project specific, then you can just start with the current working directory. Because some people want to keep all their assets one place, all the images. Yeah, I don't like that, but you can.
You said the observables are lazy. How often do you pull them?
Sorry?
The observables are lazy.
Hmm?
How often do you pull the data from
So, yeah, the answer might be it depends. But like in everything that's DOM-based, basically whenever you do changes, then all the observables, all the dependent observables get flagged dirty, which at some point reaches views, and then on the next frame it's scheduled to re-render. And you don't pull them at all, basically. I mean, the observable is invalidated, and then if you do nothing, then it would stay that way, actually. And you can pull it if you wanna, but you really shouldn't be. Like there's this bind function that I showed, and that actually has a relative, well, not as clever as it should be, but a decent scheduler inside that kind of, you know, makes sure to collate changes and that kind of thing. Yeah? Is that, how are we for time? Okay, we have another hour. Yes, Justin.
Do you have something like Redux or something like that? That
No.
basically keeps the states so you can go back to them?
It's a bit more, it's not that easy because, does anybody know roughly what Redux is? Like it's this global store of basically at any given point in time it has a piece of immutable data, like a big tree, and then you dispatch an action and that computes a new tree of all of your states. And the way that sounds expensive at first, but the way that you can optimize it is by actually being kind of specific about which parts you want to recompute, and if you reuse much and you have efficient immutable data structures, then this can actually end up pretty nice. But the point is that you have to write your whole code this way. Like all of your business logic has to be decomposed into actions and all this kind of stuff. And it's something, well, one question is whether it's really that clever, but we never had even the option to think about it because it would mean for us to just throw away everything, you know, and rewrite it in a completely new way. And Coconut is a bit more about you just, you know, you have your objects and they're instantiable and you can have as many of them as you want. There's nothing global anywhere unless you want to do that. And then you just live with that. And it might be possible, because it's all controlled by macros, to basically construct a log of all the states that you go through and then replay that, maybe. Didn't come up yet. For now, it's we still have a few other things on our plate. Okay. And yeah, to continue on your question actually, because it was two parts. So first of all, you can drive Coconut views with stuff that is not actually coming from Coconut data. Like you can build your own abstractions for this kind of stuff. If you're not comfortable with how the model layer exists there, and the only thing is you're going to have to produce observables at some point. That's like the interface to the UI. And you can do the converse where you actually use Coconut data without all this UI stuff. Like there's Steve, well, he's in the other room right now, but he has a game engine and he uses Coconut data for that. You know, I mean, I don't think everything of it, I mean, stuff that updates every frame at 60 FPS probably does not need this kind of intricate invalidation algorithm, but there's stuff that you don't want to change that often, and then it's actually quite an interesting choice, maybe even for gaming. We'll see in the future, maybe. Okay, moving on. Oh, yeah, sure.
Yeah, I know it's like you were just saying about talking about this, but I still didn't quite understand if it's like a reliable could be applied to make game UIs. For example, if we replace the render with some like OpenFL based how or whatever, and we construct custom observables from our like game data. We can, I guess, use this layer, the HXX, to like for game UIs.
You mean to render the actual UI? So yeah, I mean, there's multiple things that you can do if you wanted to. I mean, this is something that I want to actually try to do with Haxe UI, ideally, but maybe with something different. What you're going to have to do is implement a kind of like a virtual display list with diffing for Haxe UI. Yeah, it's not that big. Like you can look at Franco's Doom library. I mean, it's not such a huge thing. You implement that and then you hook it up as a renderer, which also is not that difficult. I mean, the way you achieve that is, no, actually, if you use an uppercase thing, it knows to use a class and all this kind of. So yeah, I mean, it's gonna work pretty fine. It worked fine with React, which in itself was a big challenge, because React is very opinionated about the life cycle of your views. And we're actually hijacked that to do something else entirely, but it works pretty well there. And I think it can work like for Haxe UI or something lighter, you know. I mean, you could just have the notion of, I don't know, rectangles, triangles, and all this simpler primitives and compose them in this way also. And yeah, and you get like many layers of caching in between, and most of the time it pays off, but depends on how often you update, I guess. You know, at some point you better just redrawing at 60 FPS. And Simon.
I don't do much MVC, so what would the controller part do in this situation?
There is no controller. That was the point.
Okay, so
Because controller is like this glue code that you write, and it's always very complex, and nobody really understands, and it becomes bigger and bigger, and you suffer, but it doesn't get any better. And so, I mean, there's more like what you write is more like configuration, setup, mediation, like introduction. You introduce models and views, and then they just click together, and it's pretty fine. And I mean, like this thing, for example, is called full name view, but let's just let's call this one foo, and let's call this one bar. I'm sorry. I know, yeah, okay. So this can be foo, and this can be bar, and foo and bar. And then what we're going to do here is this. I hope it still compiles. Yeah, it's amazing. And it should still work the same way. And so this component is in no way meant to render, well, it's still called full name view, but now it's detached from the idea. Like you can have purely structural components, and you can fill in the data. And so all of the heavy work that the controllers have been doing is reduced to just describe which part goes where, and then it just works TM. Or not. If it doesn't, tell me. Okay. Is that more or less clear somehow, or not? Or is the... Okay, great. So now we are going to do weird things, if you feel like that. Sorry? Thank you very much. Yeah, now on to weird things. It's who uses Git anyway. So there's that. And what was I doing here? Yeah, okay. So I wanted to. How much time do we have? Yeah. Is there? So no more questions at this point, because now I'm just going to do weird, confusing stuff, and now would be a good time to just start asking when I'm being non-understandable. So this is just an application. I wrote a bit of a backend part for it. It's like it's for editing your own gists, just like in an editor and stuff like that. So what I did already, there's a server in place that serves the application right here, and that proxies the request to GitHub because of cross-domain origin policy stuff and all this. And what's this? Yeah, yo. This is how I debug. So basically, like, if from the browser you wanted to connect to the GitHub API directly, then it's gonna say no for certain things, like especially if you're trying to do post requests. So I'm routing this through there, and but that's like not in any way the interesting part. It can also, in theory, store data for me, and at some point, like the files that I downloaded from GitHub, put them on data. There's a server call for that. It's just that right now it does nothing, but maybe we'll come to do that. But what we want to do for now is just show them in some neat UI, you know, and see how far we might get with that. Okay. So so I created this. So this is, for example, what a project is. It has a constant ID that shouldn't change over time, right? I mean, it's called a project, but it's really just it has a description. It has a directory. It knows whether it's currently saving. I made this private, so nobody else gets to control it. But you have a trivially computed and wrongly computed variable right here. That basically gives you read-only access to that. And it has some function injected from the outside that can actually save the project. So that's what makes a project. And I hooked all of that up to GitHub in this case. But there's nothing GitHub-ish in here going on. It's kind of quite interesting. So yeah, the other part of what controllers do, you just factor it out into these small little functions like this. Like I call that services. And you inject it into the model, and the model actually knows when to do that. So it doesn't know how it saves project, but it decides when to do that, so it can, you know, avoid saving twice at the same time or all this kind of stuff. It's kind of like this. In theory, it's like this little unbreakable cell that you can subscribe to and that you can call stuff at, and it should always be in a consistent state, as opposed to this. What you sometimes have are these like anemic domain models where you just have these objects that come from an ORM or something like that, and they are just very fragile, and the way that you avoid breaking things is always accessing through a thick control layer or something like that. But in here, it's kind of the models need to be strong, and the services actually serve the models. You know, that's what they are there for. So yeah, we have that wired up, and so so we have something that I'm calling the session, and that has a project ID that I can change, and it has a function for loading projects based on a project ID. And there's this interesting thing, which this is like a computed variable, but it's loaded. So the only difference is basically what's on the right-hand side is something that evaluates to a promise. That's the big difference. And actually, at runtime, it's not going to be. Do I still have the documentation somewhere? Yeah. It's maybe explained a bit better here. Loaded. Yeah. So it boils down to this type of promise and promised enum that basically, depending on where you are in your loading process, it's one of those things. So you know, at the current state, at some stage, the current project might be loading or might be failed to load, or all these kinds of things. Okay. And the thing is, as soon as that state changes, it also automatically comes through your UI, just with a different value for the enum. Okay. And so we actually want want to be able to display some such thing. So let's make, yeah, I have these really great names like app. So let's make this, I don't know, main view. Why not? Why did I copy that? Okay, anyway. Package client, I think. So we're going to create a view. Let's call this a main view, and it's going to be a view that for now all that it can really show is a project, but we're actually going to use a promised project. And I think we must import what a project is. So this is all very just proof of concept. Names are not very nice, but you can surely think of better ones. Import client project. This is nice. And so we must provide a render function, and we will call this thing. Let's call it. So let's wrap it in the div, and we'll just call this thing main view, for example, so that we can style it later. And what we're going to do. So in here, what we actually want to be doing is we're going to be switching over the project. Yeah, well, let's call this. No, let's stick with project. And we do things like, so we so there's this done case, which gives us the actual thing, and there's going to be loading. So it's pretty obvious what we're going to do here. And it could be failed. In that case, I don't know. Oh no. Class is error or something. Okay, it's not very helpful, but you know, it's better than nothing. Okay, and so let's say it's loaded. Then we should be able to, for starters, just have a header in there, and it's going to give us the description. And why did I break completion again? Oh no. Okay. I think here I have a somewhat cryptic setup. No. Okay. As I said, sometimes it works, sometimes it doesn't. And so yeah, in this main view we can now render something of this type. So let's put it into into the DOM. We don't really need this just yet. But so what we're gonna do first is, so usually within a view it's very easy to get into just to use HXX all over the place, but in this case you have to kind of, you know, be a bit more explicit about it. So we can just say the main view, and the project is going to be the session current project. And now this might build. Is it any faster now? Okay, yeah, that's better. So what's, yeah, okay, so that does not really help. So document body, oh, this works. Append child. And so this is for now a bit cryptic, but you know, it's not the top priority. This is how you mount that thing into the DOM if you want to, and write it correctly. Yeah. So it was loading for a moment there. Let's see if anything happens. Okay, that's kind of a disappointment. Let's just do something else here to see if we're actually in the DOM. Okay, so this is us. And this is a header. Oh, because I don't have a description for this. Just okay. That's awesome. Where is this thing? Just .github. Ah, no description. Okay. Well, that's helpful. Test description. Update secret. Just what? Okay, so obviously I'm not the only guy having problems. No, I'm sorry. It's just based on this. But yeah. I hope I'm not breaking GitHub. Okay, nice. That would be a bit too bad. So what's that? Ah, yeah, loading, and then it goes test description. So that's the data actually from the server. And I did no handling of anything. Like the other part is what I talked about briefly. Is this 2 days ago? Is this like definition of the GitHub API as per types, and then you just get the client generated, and that creates these promises. And oh, it just so happens that we have a UI framework that can handle them pretty nicely. And so yeah, so you can start out with that. So I don't know. I suppose let's try looking at what's in this thing. How would I do this the best possible way? Ah, okay. Because this is like this weird nested structure. It was actually stupid of me to go with a nested structure, but it's what I did. So I'm going to use this totally well-named thing, which is called flat dump. Crawl. I'm sorry. This is just random noise from me designing the model layer poorly. So we're just going to take the root directory and we're going to expand it into a flat list of stuff. Like this makes just a list of named strings, okay? Just so that you know what is happening here. So we're going to put in a few list items, and then this is going to have an h3 and maybe a text. Well, no, actually this should be an input, I suppose. Input. No, okay, let's do it that way. Why not? Input type text, and the value is going to be sorry, this of course is total nonsense. File name, and then maybe why not a text area? Text area. And in here we are going to put the file's value. I hope that is anywhere near correct. Okay. Loading. Okay, so it's basically what I have right here. Okay. So now this looks really stupid. Do we want to make it pretty, or maybe try to add some functionality, or I don't know. Anybody have? Functionality is better. Yeah. Okay. Yeah, this is why nobody cares about Haxe. Okay. So basically, yeah, this is kind of a stupid way to do it. I will therefore let's make a helper function. Let's call it directory options. So this is the actual name. And the contents. So yeah, I structured my data really weirdly. Directories don't know what their name is. I don't know why I did that. Sorry. So yeah, and so to render a directory, I suppose let's look at what a directory is. So it has this list of entries, of named entries. And an entry in turn is either a file or another directory. Okay, does that make sense? Sort of. Okay. So yeah. So let's go with class directory. So now this is kind of it's a bit pointless to draw a directory tree for a gist which has one file at the top level, but we're going to improve on that. You know, let's first write the functionality because you don't want to see pretty things anyway. So yeah, so in here we're going to switch over what the we're going to first loop over the directory's entries. This should actually be outside. So there's that bit, and then we're actually going to switch over what the entry's value is, like, because it's actually named entry, so we have to get the value. Like, that's just a name value pair. So there's this first case, which is a directory. Is that right? And this is the second case, which is a fail. And so if it's a fail, then we're going to sorry. No, what did I say? I said something like, yeah, this is more like what we actually want to be using, except that the way that the data is structured is really hard to actually rename files, so let's skip that for now, conveniently. And let's so this is the entry name in this case. We might want to prefix it with the options name. Sorry. So that's what we are getting from outside, you know. And so there's this text area, and I think we can do something like on input, maybe. I'm not really sure. Never can remember these things. And on input, we're actually going to change the content of the file to the event target value, I think. Let's see what the compiler has to say about this. Wow, thank you. Options. Options, directory. String has no field file. Yeah, that's because I wrote something weird there. Unknown identifier file. What's that? This should be F, I suppose. And this is content, I suppose. Okay. So yeah, I mean, that's kind of neat, you know, to do that without typing takes ages. And we're not rendering anything because why? Because I'm doing nothing here, of course. So in here, let's just say we want to render a directory, and the name is going to be, I don't know, and the value, no, sorry, what did I call it? Directory. Well, this is great. Let's make it this way, maybe. I don't know. And the root happens to be the project root. This also seems to do something. Okay, so that's kind of neat. No idea what this does, to be perfectly honest, but okay. Let's just check that the binding here is working correctly. So in here we'll have a span that is f.content.length characters, because I'm not really sure it will be, to be perfectly honest. Oh, yeah, okay. So yeah, now we have this type of stuff, and then there's that, and then what is the fufu? Yeah, this is the fufu. What else do we want to do? I suppose if it's loaded and we have the project, then we're going to put a button here that's, you know, on click is going to save the project, maybe save, and make this a button. So let's do all of this. No idea if this has done anything, but okay. So we could do something like disabled equals p is saving, right? Yeah. Okay, let's do something of this kind. And so where do we go from here? I should make it load faster, but anyway. So I save. It actually takes a long time, but yeah, okay. All right, and does it become evident why you don't want to do this stuff imperatively? Okay. And so yeah, and so you can do a lot of, I mean, there's a lot of things in that. One, you don't have to take care about writing down relationships. Secondly, the compiler actually tells you when you're doing wrong things, which is great because I'm really not good at remembering anything. So yeah, I mean, if you're a very hardworking person, then I suppose you can just use, well, whatever, actually, imperative paradigms. But for me, this works a lot better. And so yeah, that in itself is already pretty cool, and it's architected in such a way that the rendering bit is not that much. Like if where do we go? I'm sorry. Did you Haxe run stats for MVCoconut and which one is it? Coconut React. Like for example, the VDOM renderer that we're working with now. It's 172 lines of code, so writing your own renderer should not be that difficult, you know. I mean, in the case of, I don't know, Haxe UI, the diffing comes on top, but it's not rocket science anymore because there's just so many other implementations that you can look at and get ideas from. Okay?
Yeah, so I really like that everything is connected together and updates. That's really cool, but I still don't really understand why you have to use this XML specification. Why can't you just put Hex code there? And
Okay.
that and
So this was you could write these functions. I mean, there's so there's one thing you can't. In some cases, I mean, there's a few neat party tricks. Like there's this spread operator that you would somehow have to emulate. There's this thing, like you could, this and this, like the compiler, I make the compiler figure out which one is, they are equivalent, basically, you know. If what I provide here is a function, then it's just used as is, and if it's not, but I know that the attribute expects a function, then I wrap it in this. So this remains unmodified. This is a shorthand for actually having this written in front.
yeah, okay, I get that, but you could just pass the hex code and work from there. Like right now we pass.
Yeah. Okay. So that's one thing. Like you're gonna do a lot of transformations anyway. So
Why not use
that.
Hex?
And why not use Haxe? And the answer to that is basically where one is taste. Like some people said that because in the beginning I was just writing really like div something, and then inside that I would write, you know, other stuff. And I thought like, yeah, this is fine. Like finally I don't have to write XML anymore to render DOM. But then we just kind of decided. The consensus was, let's say, that we need to have something like that because we already had a lot of existing templates that we could basically, with few alterations, just slap in there and it just works, you know. And it's just that so many people work with HTML like markup, and it's kind of like the standard of things. And if you, I mean, it's already hard enough for all the other teams in our company that we're using this obscure Haxe thing, and if we can show something that, you know, they can roughly identify, then that's actually something in our favor.
Yeah,
I think.
I get why you use it for the stuff that becomes HTML in the end anyway, but if I see that switch and case thing, I wonder what's the point of that? Why not use switch without the angle brackets?
Well, I mean, so the point is, yeah, the question is, I would wanna, what I wanna write is something like this. Switch over the project, and then in here I wanna be writing case case done P, yeah?
Yeah.
And I like that. So now the problem is in here I have to somehow start,
Get back to HTML. Basically.
get back to HTML.
Yeah.
This is what my silly proposal in the Haxe evolution is basically about, to solve that problem. Because yes, I mean there's nothing particularly elegant about this switch solution. It's kind of nice because most IDEs, without understanding what's going on inside, provide you folding. So that's kind of neat. Whereas, but yeah, I mean, no, it's not a reason. The real reason is it's hard to do otherwise. And I was trying like really hard to write a macro-free parser for the whole Haxe syntax, and at some point I just gave up because many things were working, but getting completion into that thing was just really, yeah, beyond me, I would say. Okay.
Can the observables and the streams and everything work standalone without the coconut, like in OpenFS projects or other?
So yeah, Tink State is a completely standalone project which has, I think, one dependency, namely on Tink Core, which is what almost all Tink libraries do. And other than that, you can use it any way you want. It's just that if you remember the kind of code that we've written here, so there's this observable auto thing going on, and it's pretty clever, but it's something that actually really just works with clever runtime tricks. And there's no way, like the compiler won't like if you do this, for example, yeah, it doesn't really matter. And you make a number which is an observable auto that just returns a.0, and then you go a.0 equals 123. It's going to change, but nothing is ever going to be dispatched. And what Coconut Data tries to, what it does actually really quite well is make sure that at least the stuff that you put into your views and the data that is in your models is either constant or observable. So it's more like a helper in that regard. Okay, is that more or less clear? And then for, or
Sorry, yeah. The XML, do you always inline it?
sorry?
The XML inside your code, do you always inline it, or do you sometimes put it in separate files?
There's, yeah, so I mean right now, specifically right now, it's not evident why you want to have it in your files, but in theory, autocompletion can work with it quite well if it's in your files, and if it's in external files, it doesn't really. But yeah, if you want to, as I already showed somewhere in the doc of, no, well, it's not this one, but there's import statements that basically just go fetch stuff that is somewhere else.
Without completion.
Sorry? But then you sacrifice completion, yes. Yeah, so there's that. And there's also other cool things, because like once you start running down on this path to total madness, you can actually do other things. So this project, for example, has this small library in it, which is called Lassie. So that basically says, so let's have this, I don't know, how do I want to call this? Main view less. And it's just going to, we're just going to go with main view, and we're going to say background is pink, because yay. And no, I didn't really want that. Yeah, main view less. And I recompile now, and we can see that it's probably, yeah, it takes a bit longer than normal recompile. And the reason for that is that actually there's this library that plugs less directly into the compiler. It looks at all the types that are found that have these less directives. It takes all of them that are not DCE'd. So only those that make it into the compilation. Like if we could all right, let's just look at this to see that it kind of works. So now something should become, why is this so slow? Main view, background, pink, main class, yeah. Yeah, so this is one thing that could actually be more type safe. Yeah, okay. So yeah, so we see that it works this way, but if we attach this to some other class, let's call it useless, then we see that something is not right in the state of Denmark. Sorry? Ah, yeah, that might actually be true. DCE full. No. Okay. Then I probably just broke it. Or let's restart the server to see. It's actually, some of my macros are being too clever. Sorry? Oh, okay. Yeah, it's a hex 4 thing. So yeah. No, I'm kidding. Okay, now I broke everything, apparently. This is good. Okay, there we go. Okay, well, in theory, it can work that way, but apparently it doesn't. And then there's other things that you can do, like much like Philippe, for example, plugged in Webpack into the build. You can, like, I have this small project that just plugs in Clojure, which of course makes your compile time entirely explode. And then, no, this is not the right thing. Then you come out with 98 kilobytes of JavaScript, non-gzip. So there's, if you compress this, it's actually somewhere around 25-ish, I think, or something. So you can do pretty nice things. And like most of that thing is actually the virtual DOM library that is linked into, that is compiled into the output. So you can, sorry, yeah.
If you use this less file.
Sorry.
If you use the less file, then is it scoped to that specific component, or is it just?
No, that's a project that's actually much older, and it does not know anything about components. It's really attached to classes, and I first used that for the server side, because I wanted to. I mean, I was writing my templates all over the place, and I didn't want to manage all the less files that belong to them, or maybe they don't, or stuff like that. So I always had that attached to the class. But there's no link between those things yet, and I'm not really sure how to. But if you have an idea, then let's talk about it.
Yeah, Vue.js.
Sorry?
Vue.js
Yeah.
does something similar.
Yeah, I mean they actually make you write your CSS right in the component, right? Yeah, okay, that would be something else again, but it would kind of make it more obvious what you have to do with the CSS once it's actually in your component, you know. But okay, more questions.
How do you encrypt the VDOM library?
Oh, quite brutally.
How do you inject it in your JavaScript? Do you do it browser required?
No, it's inlined into the build. And the reason for that is that, okay, this again is something that only, you know, works 2% of the time. But let's see if it does in this case. Let's increase the build time a bit more. Okay, well, in this case, Clojure does not like me. The result of the add operator, blah, blah, blah. But, you know, I'm sure this is fixed in Hex 4. But yeah, I mean, the reason I decided to inline it is that, as said, we are kind of struggling with size issues, and we want to reach the point of using advanced closure mode at some point. So for us, it's one of the avenues that we're kind of exploring is just you put everything together and it's already relatively small, and then you put advanced closure on top of it, and then it's going to come out at a size where splitting maybe does not measure that much anymore. That's the naive hope, but we have yet to. I have yet to have success. Okay, any more questions? Or do we want to add anything more to the thing, or I don't know? Like we got 15 minutes, or we could go out faster and get our first beer earlier, as you wish.
What about progress? Like you had that loading thing. Could you add some progress information somehow, or do you just not receive that data?
In this case, it's not there. But you could build something of that kind, sure. It's just that this doesn't really come up because generally, like, all the I/O APIs in the browser are just such a joke that you cannot get this information anyway. So you're just, yeah. I mean, if you know that you're downloading 10 items, then you know you can show something that goes from 1 to 10. But yeah, the way we could do it in Flash, it's not happening yet, at least. Okay. Then I suppose we're maybe done here, right? Thank you.